Hello. So for my term project, I made a chemistry sketching software. Open it up here. As you can see on the interface right here, you have a large canvas on which you can draw on, and then you have a whole variety of bonds over here, all on different toolbars. Each one of these is clickable, and there's an arrow toolbar right here. And note that when one is clicked, every other one is off, such that only one can be drawn at a time. And you can obviously put them over here. Everything is toggleable, so the basic toolbar, arrow toolbar, periodic table, and instructions can all be turned off and then turned right back on, like that. All right, let's get to it and start drawing stuff. So you can see when you're drawing single bonds, as you click on each one, another one appears in series, and you can draw cool ring-like structures here, do long chain tails. And in chemistry, it's very important that you can't have 5 bonds to carbon. So note there's 1, 2, 3, 4. No matter how many times the user clicks on it, the 5th bond will not appear. And this is true for all different locuses. All right. Now, one of the cooler modes you can enter is called intuitive mode right here. And note, in chemistry, often you just draw structures like this, and chemists understand that that's a CH3 and that's a CH2. However, the user might not be a chemistry student, and so it can be helpful to have the bonds explicitly written. And note that this is CH3 on the end with 3 hydrogens right there. However, at this point, there are already 2 bonds, so the CH3 shrinks down to a CH2, and in turn shrinks down to CH. All right. There's also undo and redo functionality. So after drawing a large amount, you can undo the bonds in order and then redo them. However, as with all undo redos, once you draw another bond over here, redo does not redo it. All right, let's draw something fun. Now, we have a whole variety of different bonds. Note that this is a double bond and it comes out at what would be an appropriate angle for it. So over here, it's going to come out facing down, and up here, it'll come out facing that way. Also note, double bonds cannot be placed where there would be 5 carbons. Triple bonds, this is also true, and triple bonds also come out at an appropriate angle. Now, we have cyclohexane right there. We have benzene right here, and we have cyclopentane right here. And note that for each one of these, it's attached at an appropriate place. So let's clean up this canvas, it's a mess. So over here, it's going to attach right at the bottom where it would be found, and right here it's going to attach at the top right. This way it's not lunky and it attaches in the right angle. All right, starting it over here. So you can draw a long hydrocarbon chain. And then one of the cooler features is you can get the chemical formula for this. And then from that, you can get the molecular mass right there. And let's see here, let's make it interesting. Let's give it a challenge. Let's put in like a silicon. All right. Molecular formula C16H33SiH3. C16H33 SiH3. And let's calculate it. It's found to be 256.54. 256.54 right there. Works completely accurately. Another thing to be noted is right here with the additional placement of an element. Let's talk a little bit more about that. The periodic table right here, every single element in it is highlightable, and of course, as per usual, you can only have one element highlighted at a time. All 118 are featured in here with some relevant information. And now with each one, when you place it down, let's place carbon right here intuitively, it comes down with the appropriate number of hydrogens at that point. And another fun feature is if you put down hydrogen, it turns into a CH3 as opposed to a single hydrogen. And this is true for all elements with the correct number of hydrogens right there. All right. My software is also able to name. So naming right here. Start with ethane, go to propane, butane, and pentane. Now, let's put in an O. See how this shrinks for the appropriate prefix. So pentane, pent is 5, butane, but is 4. So there's 1, 2, 3, 4 carbons, and the null symbolizes the OH right there. And then if you take a second oxygen and place it down right here, you get the propane diol with the 2 oxygen locations. And let's do one more, some nitrogen. Let's go back to our friend pentane. Place down here, nitrogen noted as NH2 at the end, you get butanamine, and then placement of another one right here, you get propane diamine, the 2 amine locations. And there's also a couple other organic molecules that have been added, like toluene right there. All right, thank you. Bye.